All right, I think we're good to get this to work. Find out. Our first exam is when? Next week. A week from today. So we have 3 topics to get through until we can begin a review. Hopefully we can begin a review. Obviously, I plan to. I'm looking for a connector here. Yes, please. Let's see if this works. I'm trying a new approach, and we might have some. Might not have one. Yay! All right, it's cool. Let's see. All right, so I want to re-emphasize the importance of transformations. So officially, hello, I'm ready to go. Sorry for the delay. Definitely a major topic in pre-calculus. So normally I kind of move on and say if you had questions, resolve them with me, email, tutor, after office hours, YouTube video, homework, however you remediate when they're like a little gray in a subject. But this one I am going to take a little more time and just really make sure we drive home the point of it. So everyone's got a PDF and a handout with a graph of a function. So it is a function because it passes the vertical line test. Just kind of remember that. Sorry, making sure my dogs have a babysitter. And they do. All right, so transformations. I want to graph y equals f of x plus 1. We want to know that adding 1 to a function graphically shifts it up 1. So we're simply going to take this set of ordered pairs, well, there's a few here, and shift them all up 1 unit. Connect them. And that's it. You will not be successful on the exam if you do not know that transformation, what it looks like, plus 1 outside of a function. You will not be successful on the exam if you don't know that it's called a vertical shift. And you will not be successful if you can't sketch a graph. So you need to know your transformations, along with a plethora of other material. But you cannot show up, or you can, but do not expect a decent grade at all if you do not know transformations. Another transformation that we looked at is something like this. Graph y equals f of negative x. A negative is a reflector, and you can reflect over the y-axis or over the x-axis. You need to know if the negative is inside the function. When I say inside the function, this was inside, then it is a reflection over the y-axis. So that means this point over here, that is 1, 2, 3 units to the left of y, is now a mirror image 3 units to the right of y. 1, 2, 3, right there. So gets reflected the other way. That's what a mirror image is. If this is a mirror and you're like, whoa, I'm 3 away, now you're gonna be 3 away from the mirror. This point down here is 1 away from the y-axis, reflected over. And similarly, this kind of makes sense to me since that line is kind of like already symmetrical about the y-axis. That point right there is reflected here. So if I call this like point A, B, and C, B reflects to C, C reflects to A. So it's a little bit lost there, but it actually took place. Point D, this might be helpful thinking of this point D. D is now 2 units to the right of Y. We're going to sketch it 2 units to the left of Y. 1, 2. And point E over here, which is 3 units right, becomes 3 units left. And we trace our curve, or function, I should say. Really no curve there. And it's there, it is there. Yeah, it's a reflection, like the mountain was over here, now the mountain's over there. And this kind of wavy line segment, or not wavy, but line segment is now over here. A reflection over the y-axis. Need to know that. Moving right along, we have a lot to do. F of negative x also is a reflection, but it is outside of the function. So trying to emphasize inside transformations, outside transformations. For every inside, there's a similar outside transformation. So if you're inside negative, it's a reflection over y. If you're outside negative, it's a reflection over x. So same story, except not counting from the y-axis, but counting from the x. This is 1 above, we go 1 below. So A goes 1 below. B, which is 1 below, becomes 1 up. C, which is 1 below, becomes 1 up. D, which is 2 above, goes to 2 below. And E, which is 1 below, goes to 1 above. Boom, 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 boom. Done. F of x plus 2. I'm going to scale out for a second here and refer to the thing right above it. This is a +1 outside of the function. This is a negative inside the function. This is a negative outside. This is a +2 inside. You ready? Yeah. Okay, so an inside effect is not the same as an outside effect, but it's similar. This outside effect in letter A moved it up 1. The inside, so I want to use the word shift 1. The inside effect is going to shift it, not up, not down. Which way? Left 2. So we, good. Inside kind of opposite is what goes on in my phrase. That's like my little catchphrase to myself. That's how I know this. So I associate adding 2 to the right. And please do that in other math courses. Please almost always think of adding 2 means moving right. But with function transformations, we had already explored it last time. Today we're just emphasizing inside opposite. Do not say right 2. This is a left 2. So literally every point just says, yo, move left 2 units. To the left. To the left. I feel like I'm Beyonce. Everything you own in the box. All right. No. And that's it.
It's a horizontal shift, right?
Horizontal. I didn't move it up. I didn't move it down. Point A to the left. Point B is now to the left. Point C, the thing that's hidden under here, is to the left. The mountain peak, to the left. The bottom of the mountain, to the left. Everybody moves to the left. Letter E, stack some transformations together. We have an outside negative, got to know flip over y. Sorry. I did motion, I said the wrong words. Wrote reflect over x. So everyone's gonna just reflect. And then shift left 2. All right. So we kind of hover our pencil like this. We go reflect. You do it, by the way, you do it in the order you see it. So, like, what do I do first? The order you see it. Reflect, left. Reflect, and then left. So I'm going to undo that. I'm here. At this point, reflects upwards 1, and then left 2. Reflect, left 2. Reflect downwards, left 2. Reflect up, left 2. We've covered 4 of the 6 transformations in past 10 minutes already. So before I move on, it's good to keep saying them over and over again. Inside, add means left, whatever that. Inside subtract means right. Inside negative, reflect over y. Outside negative, reflect over an x. Outside add, move up. Outside subtract, move down. Last transformations are multipliers, both inside and outside. They're called scaling. You can stretch something or you can shrink something. We'll use the words in a minute on the back side of this, you'll see, right? We're talking about right now. And then inside multiplying by 2. Similar vibes, at least I learned to say inside opposite. I'll say the story again. You know, if I tell you I'm gonna multiply your bank account by 2, you have to associate the word stretch or shrink. I can shrink it if I multiply your bank account by 2. You'll probably then say, well, it has to be stretched. If I 10 times your bank account, your Roth IRA or your savings if you have one, not say I shrunk it, I stretched it. Unfortunately, on the inside, it's not a stretch of 2. I don't even know if it's an unfortunate, but it plays well with the inside opposite. Don't say stretch 2, we're gonna say compress or shrink by the reciprocal of 2 called a half. All right, so now I'll say that nice and clean. What do I want you to say here? This is a stretch, false. This is a shrink of a half. This is a compression of a half. Now what the heck does that mean? You measure the distance from the y-axis, just like we were doing a reflection, but we're not reflecting, we're just gonna take half of it. So point A is 1, 2, 3 from the y-axis, compress it. It's now going to be 1.5 from the y-axis. So 1.5. Point B is 1 unit from the y-axis. We are going to compress it by 1/2. So it's now at a half. Point C is 1 unit right. We're now going to make it a half a unit to the right. Mountain Peak, point D, 2 units, half of 2 is 1 unit. E, or the bottom of the mountain, 1, 2, 3 units. We're now gonna go 1.5 units. 1.5. And we've compressed the shape horizontally. We shrunk it by 1/2. Letter G. We have an outside multiplied by what's up.
For the previous one, if it was F4X, would that be a quarter?
It would be 1/4. So I probably wouldn't ask you to do that because, but in words, that would be a very good question. So if this happened to be a 4, we would say horizontally shrink, horizontally compress. I don't care which one of those 2 words, but I want the word horizontally shrink or compress, and you flip your number 1 over 4. Let's do this. Suppose it was 1/3. It's not a shrink, it's not a compress, it's a stretch. But you don't say I stretch my bank account by 1/3. What do you think we're gonna stretch it by? 1/3. So you're always flipping that. Gonna be massively important when we do trig graphs. If you already had trig graphs, you heard of 2 pi over b for the period. Over b. So if there's a 2 there, we're actually doing the reciprocal. And if you made the connection cool, if you've never seen trig graphs, it makes sense once we do get there, right? It becomes fundamentally important with trig graphs. Okay, and I showed that a little bit last time. Anyways, moving right along. 2 on the outside is not inside opposite, so I'm gonna say it's a stretch. And it's not horizontal, because it's on the outside, it's vertical. It's vertically stretched by 2. What does that mean? We're gonna go from the x-axis, this is a height of 1, we're now gonna double it. So it would be at 2. But I have one other transformation to apply, then shift it down 1. So in one clean motion, double the height, but then subtract 1. Double the height
Oh, because it is -1, okay.
and then subtract 1. So brings it right back to itself.
Okay.
That's not gonna be true for everything, but we'll see. Double this distance and then subtract 1. Oh, this is kind of boring.
Wouldn't it go down 1 to?
Oh, yeah, because why am I moving it up? There we go. I was saying something's, okay. Try that all over again. That's completely. This is the height of 1. Sipping my invisible coffee. Did I double it? And now I'm moving down 1. We're in agreement. Try this again. This is a height of -1. It's a depth of 1. Am I to double that? Depth of 2, and now move down 1. Thank you. This is by the same thing. Double, shift down 1. Mountain Peak has a height of 2. Double it has a height of 4. Shift your pencil down 1. Double the depth, move down 1. And that's a little bit messy. I probably could have done better, but the idea is there. Okay. This object got shrunk horizontally. This object didn't. It's like, you know, how can you make like a silly face photo, you take your photo and then like you just stretch it this way. So in this case, we took a photograph, it stayed here. We didn't do anything horizontal, we just kind of pulled this way. Of course, it looks weirder, but it didn't change any horizontal. I just want to stress that. Obviously, I am. Cool, here's your first challenge of the day, so I'm not barking at you, and I'm right on time for the first time. Right.
Why'd you say that? Now
I'm always like behind my.
Even though you jinxed yourself.
I know, right? I'll be So there's probably more than one way, but I think we'll all technically get the same answer. So there may be more than one way. Attempt to write this graph. Y equals what? What do you see here? And then take another couple minutes to yourself and summarize in your own words your understanding of transformations. I don't want to say much more because I don't want to guide you in your summary. But summarize transformations. That can be a paragraph, that can be a bullet point. This is nothing formal. This is almost a message to yourself. What do I need to know? What are the main points? How am I going to remember this for an assessment and beyond this course? Maybe not forever, but at least your mathematical career, that's this semester and any other math courses, at this level, you definitely want to know transformations at a super high level.
How do you word inside and outside? Like the equation?
I just say if it's in the parentheses, it's inside, versus if it's not in the parentheses, it's outside. And I'm going to just guide this the tiniest bit, because if you do any web sleuthing or you take another course or a textbook, you're probably going to see A times a function B, X minus H. So B and H are inside. They're like inside the function. This is F, B and H are inside. A and K are outside. So you should be able to say, A does this to a graph if blah. B does this to a graph if blah. H does this to a graph. K does this to a graph. I need to excuse myself for no more than 2 minutes. So this is a good time for you to attempt to write this, turn to a neighbor, say hello, how's your Thursday, Wednesday, whatever day it is, Wednesday, and share out together, agree to disagree or agree to agree, and then maybe talk about what you wrote versus what they wrote. Again, there's no wrong answer here, this is your summary, your own words, a note to yourself on how to study this, what are the main points. Maybe by talking to someone who writes, oh, I forgot about reflections. Oh, I forgot about horizontally shrinking or something like that. Oh, I forgot it's like inside opposite. All right, so we got it in 2 minutes.
You feel that in your bones, you feel it. It's just moving. Yeah. That's good. Do you have a question?
No, I saw no.
Which one is it? Which way? Go ahead.
This horizontal line.
If you wanted to reflect that, what would you do to it?
Inside the function. So y f and x.
So the important thing about your reflections is the inside of the function.
Good for you. Well, I started this
So,
week.
except with reflections, you have to think about it differently. The outside of the function, it changes the line
So you want
as a
to
reflection form. So you change
Right,
the
like I don't wanna have to,
line.
yeah.
Yeah.
Is this?
No,
Finding mystery, the behind back.
lines at
So,
negative one was like a graph, but I negative that minus one line. What's the negative? Yeah. Okay.
So basically,
So,
basically.
Let's go to example
see,
Yes.
And then.
Yeah. So example C.
And then I go back.
Whatever that y value is, after that, tells us what the y value is. When we choose that function, we get a y value. Yeah, you're going to put a negative in front of the y
I
value.
think that's.
so your function outside of one.
Entire days.
Yes. So when you reflect, I would tell say positive one, negative one. The y value is no longer on one. It's on negative one. You reflected it across the x axis.
Okay.
Does that make sense? And so if you were to reflect it in this example, if you would put it inside of that student. Does that make sense?
Yeah, so I started.
Did you really like that?
I started.
You went over just these.
So what do you, so,
Can I like say? So I said.
which way?
Plus or minus in front of the negative. Plus or minus is a reflection Yeah, I wrote it down. This doesn't work. Plus is left on space, minus is like.
So I could use this to describe a.
And then minus is in front, it's a shrink.
What's the first?
And then feels like it should be.
And then if it's outside,
Yeah.
it's a stretch. But that. We got three, would it be, I move six, would I go? If it was.
I'm not sure that
That's six. Only doubling it because it's two.
And then would it be plus or minus?
Yeah.
So
So
decide, add or
So all of the line is now, so it's as well. Three.
Do we?
Three spaces from the line, or is it three spaces from the axis?
From where.
Wherever it is now.
And then it's
like I said, it's all about
One
there.
that
Really?
or
Or
two
plus?
or at least mine was one that would be at the right spot, so. I don't know, I wanna ask.
Right now, somebody down like
That's
confusing
the only one I'm not
myself.
clear on. But then besides that, I put also at the end, also.
Okay, so that would make sense.
The whole equation is at the end, or plus or minus, plus means nothing.
I know why. So let me see.
I just kind of.
If I take, I'm actually taking.
So.
It's easier if you do this.
One, two.
Yeah. So
So if I follow your.
Anyway, in any tone other than supportive, I would
We double that distance.
Yeah, no, or you explain things.
And I would
Really helpful.
shift. Perfect. So that makes me shift first down. So pure.
So.
Way or.
negative F, yeah, for reflection over the X axis.
You know that is,
It's a formal.
look at letter G from, I'm gonna continue to talk about this. So if I measured how tall the original mountain was from here, from here, we'd say it's a height of 2. Now, from here, if there's a stretch, it's gonna be a height of 4. So kind of from like that midline. So here's, yeah, there's some reflection, but it's still from here, a height of 2. Finding the A value to everyone, because everyone's listening right now, can be tough, no doubt. That's why I said this is a challenge. Great job, by the way. You have everything else, it's just not a ×2. It would have been easier if the original graph was there. So put it on yourself. Put it on yourself. I'm going to put the original graph in green right here. Right here.
Oh.
There's the original.
Yeah, because if that was at.
What is something that obviously is striking here, besides the lime green?
Different points.
Different points. Obviously, there's some transformations. Awesome. How might I, I want to get going. I want to think about, do I need to multiply outside? And what, obviously, on the final graph is going to say, yes, you need to multiply. In like kids' words, nothing fancy. I've been calling it a mountain. It's pointing downwards, right? If we look at your previous examples, that's still pointing upwards. That's still pointing upwards. The only mountains that are pointing downwards from previous examples are letters C and E. Context clues. Look at previous examples. We definitely need a reflection. Go ahead. If it's what? What's your question? If it's,
If the X is in half. Yeah, they're, not.
We did actually have a question on the G.
I'll come back to G after.
Okay.
Cool.
Well, it was for the explanation part of it, it's.
Definitely need a reflective outside. So now I'm thinking, boom, I'm over here. And my gut feeling is I'm just curious to try something. I want to try moving left 1 and down 1. That's what we need in the workforce. You don't need to do graphs in the jobs you're going into. But I'm only going to hire people, and your boss is only going to hire people who are going to say, I'm going to try something. I'm going to be innovative. And if it doesn't work out, I'm going to throw it in the bucket, and I'm going to get back to the board. So I'm going to try moving left 1 and down 1. That would work. So I should now check if it's going to work everywhere. Reflect, left 1, down 1. That works. Reflect, left 1, down 1. That works. Reflect, left 1, down 1. That works. I already got this one to work because my finger's still holding it. Reflect, left 1, down 1. That works. Cool. So a little bit of guess and check. What moves left? What moves down? If you got part of that, cool. If you got some of that, awesome. If you got none of that because you're afraid to fail, get out of that mindset. It's a mindset that's holding you back. If you never try, you're never gonna even get better. These are the opportunities to do it. Summarize the ways you can transform a graph. I'll use my summary, you use your own. A, must knows. Something to yourself. What's true about A? This is if it's bigger than 1. Stretch vertically. If it's a proper decimal or fraction, it's a stretch. And it's not a stretch, bless you. Don't sneeze when I'm talking. Told me right up. No, don't do that. Hold on. Seriously, it does happen. Shrink vertically. Can A be any other number besides greater than 1 or in between 0 and 1? Negative. And if A is negative, it's a completely different kind of reflection. You still multiply outside. It could be a negative, and it's going to be, if negative, a reflection over X. If you draw an arrow this way or that way, whatever you need to do to study, you have to do it. B, almost the same argument. I'm not going to use that green because it's not elegant. I'll go blue. If it's greater than 1, it's a shrink horizontally. Furthermore, by its reciprocal value, just flip the darn number. If it's a number between 0 and 1, then it's a stretch horizontally by its reciprocal. That actually makes sense. Hear me out. 1/2, we're going to associate a fact. It's a stretch by the reciprocal of a half, 2. We're stretching by 2. So this is 100% correct. H shifts left if I see a minus sign, a plus sign, or right if I see a minus sign. And to me, those are my inside effects. I got one other thing that I'm missing. I just remembered. But let me put it out there. What else could be B? Negative. So if it's less than 0, it's a reflect over the Y, which means that or this. You're going that way or this way, however you need to study it. Okay, so back to my highlighting thing. What do I mean inside? These are inside the function effects. And I don't know how many times I said it. I'm going to make up a number. 7. I've said it 7 times so far. I associate inside opposite for the, I'm going to say more, but no more tonight. If I multiply by a number bigger than 1, I think that's stretching my bank account, not shrinking it. And that is true for the outside vertical effect. But on the inside, it's the opposite of my instinct. It's the opposite of what I think. So when I see a times 2 on the inside, it's a shrink by a half. When I see a 1/3 on the inside, it's a stretch by its reciprocal 3. And similarly, inside is going to move horizontally, which means left or right. And I associate moving to the left with the negative sign, inside opposite, left. I associate subtraction with moving to the left, inside opposite moves to the right. Those are your inside effects. That's why I say inside opposite. I'm not saying it. Here's one outside effect, the last one's right here, K, called your vertical shift. Up if positive, down if negative. Must, absolute, no's. So shifts up with a positive sign or down with a minus sign. You had a question earlier about G, is that true?
Yeah, Oh, yeah, okay. Sorry, I'm like writing stuff.
So, we were thinking if it wasn't a 2, like, let's say it was like a 3,
I can do that.
would it be, okay, so from the 1, would it be like, would you move 3 spaces and then take away 1? Or like,
Let's do it. Stop throwing stuff at me. I'm teasing. A, measure its height. 1, triple.
Okay.
Now shift down 1.
and so if that original point was a 2, and let's say it was like the F, or in front of F was 2.
This is a depth of 1, triple. Shift down 1. That's going to triple. This is a height. This mountain peak is a height of 2, 4. I'd have to go up to 6, and down 1 to 5. Probably be up here. Depth of 1, triple, shift it down 1.
Yeah, and so whatever that number is after you multiply it, it's from the axis, not from the original point.
From the axis.
Okay.
That's what we're measuring it in regard to. Because the output here is 1, which is how far you are from that axis. This y coordinate here is 2, which is how far you are from the y-axis. And if we triple the y coordinate, it's now 6 minus 1 makes it 5. You could literally do it that way as well. You could literally say this y value is 2. 3 times 2 is 6, minus 1 is 5. Even though I just said that, and that's 100% true, we don't always know y values. Instead, you just want to still associate like it's stretching it, shrinking it, et cetera, et cetera. But it's so fundamental. Do something that makes sense to you, and it's not going away. Like you'll see, I keep saying that in other course. Other parts of this course. Okay.
So do you mind just going back to the bottom, just like finish copying that?
Flip over your page. Other must knows, and then we're gonna be done with transformations in the next, I don't know, roughly in my mind, 15 to 20 minute drive, and I'm gonna use the last bit to move us forward. We have 2 more sections that kind of play well together. And then that's the stuff. So the sooner we get done, the more time we can do review in class. Not today, but next week. Transformations apply to very specific functions. Here is some other must-knows, and I'm going to add a page in between here, wherever it allows. How come that just did that? No, I want a blank page. Plain, thank you. No, you're not doing that? Plain. I got a new computer, a new app. I think it's working more smoothly, but I'm still learning a couple new things. All right, so must knows. In addition to transformations, y equals the absolute value of x is a V-shaped graph. Whose vertex is at 0, 0. Why is that 0, 0? An eighth grader could tell you why. An eighth grader would create a table of values, start by plugging in 0 to find y, and they would output 0. That's why, not just because I told you, because if you point plotted this, you would get that. And if you point plotted x is 1, what's the output going to be? What's about -1?
1.
So now you have 3 points on a graph. And if someone said, yo, sketch me a graph of x minus 3 plus 7, if I know these 3 points, and I know to shift right 3 and right 3, I said it, I didn't move my fingers right, this entire thing's gonna go and up 7. That would be pretty simple. Or if someone said, yo, think about this thing's graph really quick. I could be like, in my mind, reflect over x and then down 8. What's going to be fundamentally important for calculus is that you know you're going to have a maximum right there. That's how you're going to use this in calculus. You're not going to have graph paper. You're not going to do these. This is what you need to know for calculus. Shapes, and that you quickly know, bro, the maximum is happening right there. Everything else is opening downwards. Or in this graph, you're going to say, I can figure out where the minimum is happening. That's the strength of knowing some graphs apply to their transformations. You will see in calculus. I hope you take it. It's a super interesting course. It's not more of the same, just algebra and trig. You start applying the stuff in an interesting way. But knowing these things makes the learning of it so much easier. Square root. Must knows looks like this. I don't know how to call it. Not a V shape. It's just the square root shape. And it has 3 points. Actually, it has a lot more points, but you should know 3 points on it. And again, an eighth grader would say, I'm going to sub in 0, output 0. They're going to sub in 1, output 1. They're not going to sub in 2 without a calculator. What's the next number going to sub in? 4. Cool. We went over this stuff, making sure you got it super, super strong. So 0, 0, 1, 1, 4, 2. Just remember that. And very similarly, we can now transform this a lot of different ways. We're going to short very, very soon. Y equals x squared is a U-shaped parabola. That's its, slow down. It's a U shape, not a V shape. So make it round, also important for calculus. Points on graph versus curves on graphs have fundamentally different paths in calculus. So really? Yes, it means completely different things. Smooth curves. Boom. Not a sharp point. But you have this graph. You know what I'm going to say. An eighth grader would plug in points 0, 0, 1, 1, and negative 1, 1. Very similar to the absolute value. If you needed more, you would plot point. But 3 is good. And we're going to transform it in a variety of ways. On the back side of your paper, one more fundamental thing of all of this, and then there's no more. You can literally do everything if you know some shapes and you know your transformations. The last thing I got to tell you is an algebra step, and it's factor the GCF, or just factor the inside. Spoiler alert, it's going to come up in 1 minute. I'm looking at this. And I'm definitely vibing absolute value in my mind. So I'm thinking V shape. and I'm about to apply some transformations to the absolute value graph. So the first thing I'm gonna do is sketch an absolute value graph. 0, 0, 1, 1. Maybe I'll do even more points. I know it's going like this. It's a V shape. I said 3, but here. So this gives me a vibe of what's going on. And I'm gonna use a dashed line because that's just my guide. It's like the gray on the front of this. It's your guide. It's not my final answer. I don't have anything more to say except I just have to show you what to do here. This needs to be factored so it looks like this. Undistributed 2 and make it a group of x minus 3. And now we can step back and see why that was important. Someone would say super warmly, that this is inside opposite to the right 6 units. Unfortunately, they're wrong. We're going to see it in a second. Is if you don't factor, you're not going to get the right answer. It's going to be to the right 3 units. We'll see on Desmos. That's the only way I can prove it to you. Factor and now apply our transformations. Here we go. Inside multiplier of 2 means, I'm going to zoom in on this. Well, it means this distance right here of 3 is not stretched to 6, but it's halved to 1.5. Kind of thinking that right there. Then we're going to move it 3 units to the right. So I got my pencil hovering here. Now I'm going to go 1, 2, 3 units to the right. I'm hovering my pencil. I'm just showing you my marks. I'm going to erase them in a second. And then up 2. Up 1, up 2. That's my final positioning. Lost my eraser. Where is it? Over here. Okay. So again, half the distance, 1, 2, 3, up 1, up 2. Where's the vertex going to be? We could do this with every point, and I'm watching the clock. Let's kind of fast forward this. Half the distance from the y-axis. Still there, right? Go to the right 3 and up 2. We'll be at the point 3, 2. And I know this is symmetrical. So I already know this point is going to be there. A different idea coming into play. Isn't this a symmetrical shape? Yes. So if this is the vertex, and that's 1.5 away there, and you're going to have 1.5 away that way. If you don't want to use symmetry because you're like, oh, that just came out of nowhere, then use your 3 points or 5 points. Let me take this, half it. 1, 2, 3, up 1, up 2. But watch, you would half this. 1, 2, 3, up 1, up 2. Symmetry. Here's a nice 1.5 because its distance is 2. Now it's 1, 1, 2, 3, 1, 2. Half the distance, 1, 2, 3, 1, 2. All of those 5 points would line up very beautifully to that graph. It extends onwards and onwards. I'm not going to switch over to Desmos. If you're like, is he lying to me? No, I'm not. Plug in a point, 3, 2. 3 makes 6. Take away 6 is 0. Add 2 makes 2. If you thought it was over 6, plug in the point. It's not going to be true. What's up?
After we factor it, would it always be true that the B and K will be the vertex point? Yeah.
As long as your vertex of, so for our graphs, they all start at 0, 0, yes. But a graph like cosine in the future does not pass through 0, 0. So, story for another day. But if it starts at 0, 0, your vertex will always be HK. Yeah, because, I mean, you can talk it out. If there was a vertical stretch of 3, take 0 and slap it times 3, it's still at 0. If you horizontally shrink it or stretch it, well, 0 isn't going anywhere. So stretching and shrinking a 0 bank account is doing nothing. The multipliers don't matter, only at 0. So your shifting is where your vertex is going to go. As long as it's at 0. For future graphs, we're going to see a vertex is not at 0. Well, we have to be careful, that's all. What are the transformations? Horizontal. Stretch or shrink? Or compression, whatever word you like. Shrink by how much? Awesome. If you can say this confidently and you know it for 1 week's time, in a week's time, you're in a good position now to do well on the exam. Let's make it positive. -3 on the inside.
Right.
What about right 3? Shift right 3. What about +2 on the outside? Shift up 2. As we can literally see happen too. Execute it, name it, and now tying in something from like a few sections ago. Domain and range from a graph. It's going forever. The arrows means, if I think about moving to the left, it's forever moving left. It's forever moving right. That means my domain is forever in both directions, all real numbers. Symbolized as that. Range, it's not X's, it's Y's. Ceilings and floors, if possible. Definitely come with a floor. What's that Y value? 2. Any ceiling? Nope. 2 to infinity. Next, new function. Square root. Got to know its basic shape. Got to know the 8th grader 0011 and 42. 3 points. Sketch it. 0011 1 2 3 4 2. It's going onwards that way. That's like our what we actually call parent. That's the parent. The next thing I'm going to look at is immediately learn to look at the inside and say, is that factor? No, I got to factor because there's a -1. So factor the inside, take out the negative sign, makes this a +2. Check my work yourself. But undistributed negative, that's going to turn to a plus. And you can very quickly see how a student can get this wrong. I don't want you to. Let's do the graph of this. Zero is not reflecting anywhere because it's right here. It's not reflecting that way either, but it is gonna move to the left 2 units. Point B. Read it in order. Reflect, because it's 1 unit up, reflect 1 unit down. Now, the next thing says, reflect where you're at. If you're 1 unit to the left, reflect it 1 unit to the right. That face is telling me I missed something. This is downwards, and this is left or rightwards.
And because that limit is zero,
So,
obviously it's not going up or down.
Up 1, reflect down. Now, the next thing says, left 1, reflect right. So right here. Move, left 2. Height of 2, reflection means depth of 2. I'm gonna say a new word that just crossed my mind, I'm still learning. This is east, 1, 2, 3, 4. So reflection means west, 1, 2, 3, 4.
Now I need a compass for this class. I'm out.
If you don't like it, then don't, just try to help you guys. Lastly, 1, 2, how come I lost my spot? Down 2, reflect, 1, 2, 3, 4, and then 1, 2.
No, you're 1 to the left.
Why am I off here? This is right? This is
Yeah.
right.
It's not, something's off.
Yeah, it should be on -6.
1, 2. 1, 2, 3, 4. 1, 2, 3, 4, left 1, 2. Okay.
Oh, it's because it's like open.
2 downwards.
Yeah, weird. It like, it looks better when you draw a line, I think.
And then 1, 2. So it's kind of like going like,
No, it would be like, wouldn't it?
reflect downwards. Oh, yeah. I'm just like this.
Yeah, yeah.
Took me a minute. Need caffeine.
So if the reflector of 4, then move 2.
It took me a minute to actually say, like, literally take this shape, so now it's like,
Down here, then just flip.
and then rotate it. That's how I had to like do it. Not connect those points. Yeah, there we go. So opening downwards, it almost like if that was all connected, it would look like a parabola opening that way. So then you're like, okay, make it go this way. You have a parabola opening this way, and now I see it better myself. My bad on that. All good. There we go. What are the transformations? We did them. Put them in words. Reflect over the x-axis is that. I'll just circle it. Reflect over the y-axis. And inside, shift to the left 2. What is the domain of this graph? Well, I can't act this way, so I'm forever negative, but I can trap it right here. Up to -2. And then that's it, there's nothing else. The range arrow means pushing it down, even if it doesn't look like it, tell you, yes, it is. But there is a definite ceiling, there's a definite maximum of, what number is that? Cool, just making sure. I know it, I want to make sure you got it, so, infinity to 0. Almost done. know your X squared graph. See if you can do this one yourself. If you don't want to mess up your notes, do it in pencil. If you don't want to do it, then just think about it in your notebook. What is the parent function? What do you do first? You build the parent over here, like little dots. 0, 0, I'm gonna say less. And then you say, all right, shift those 3 points. Stretch, reflect those 3 areas. Transform those points, connect it, state the transformation, see if you can state the remaining range. 2-ish, 3-ish minutes. Only look up when you're done. The answer is on the board. Only look up when you're done. Check your work. All right, if you're still working, I hate to interrupt your good thinking, but if you could just kind of pause where you're at in the next 10 to 15 seconds, because I do want to move on. And before I kind of close it out, must knows. Already went through number 2 from earlier today. You need to summarize however you understand the transformation, as long as you got all the parts. Recognize the form, the structure, know all the transformations, that's number one. Must know the general shape of absolute value, square root in x squared. Then takes a little study. You're here, not everyone's here. Not everyone can cut it. You can't. Find some time. We all have jobs, friends, lives. We need mental health. We want to have fun with our friends. But I was in college, and I didn't at first. And I was good kicked out. So I don't want you to spend 8 years. Have fun, but also lock in when needed. Study the graphs, the transformations, and practice your homework. You always should, but I've been locking in on this lesson the hardest so far this semester, emphasizing its importance. So when you're doing this homework, make sure you're locked in. I recommend AirPods out, get your distractions, and maybe chunk it. If you can't do it in 2 hours, don't. Say, I'm going to do 20-minute intervals. I'm going to lock in for 20 minutes. Whatever works for you. So those are your must-knows, and then execute it, right? And I'll talk this one out. So if you know your transformations, you know your 3 graphs, continue to execute it, and you just apply your transformations. A reflection over x means if this is a height of 1, we're at a depth of 1. The next thing I see is a vertical stretch of 2. If this is now a depth of 1, means double it. It's a depth of 2. The next thing I see, there is no horizontal reflection. If there was, I would move horizontal. But the next thing I see there is a right 1 unit. And then up 2, boom, boom. 1 of 3 points. Vertex. Someone very wisely said it's going to be the h and k value. The answer is yes. But let's just confirm it the long way. Reflect, 0 is not reflected. It's on the axis, reflect. I'm not going to know anywhere. But stretch 2 by 0, that's like taking a 0 bank account and doubling it. You're still freaking at 0. Move 1 to the right, up 2. That's why the vertex is going to be your shifts. Because the 0 just destroys the multiplication. All right, let it go. Last point, C. You could use symmetry if you're super confident. That would be the shortcut. If you know that's the vertex and this point's here, just bang that one out or go through your transformations one last time. Which would just say height of 1, depth of 1 is the reflection, stretch it to a depth of 2, right 1, up 2, there you go. What is the domain and range? All reals. Nothing is trapping it left and rightwards. And now we have a ceiling at 2, but no floor. Put it in order. Floor, ceiling, no left, no right. But if there was a left and a right, it has to be in that order. Big section to know. We have 2 more to go through. Here we go. Did we start this last time, Paul, combining functions? No. No, there's no reason for this. You're just gonna follow along. This is gonna be a little breath of fresh air. I know we're probably mentally exhausted, maybe feeling confident. I hope some level of like, I'm not 100% there, but I'm not at 0. So if you're at like the 50 zone, like I got some of that, I need to internalize it or higher, awesome. If not, I'm available for office hours in just 15 more minutes. Let's get started here. This next part is going to be light. Combining functions. I'm not talking transformations or graphs anymore. We're just going to say, let's do some algebra. Suppose I have a function and a different function. Can I add them together? Heck yeah. It's as simple as adding them together. Here we go. F add G. This literally means add F to G. So we're going to write 3 minus x squared. Add g. We say, can we combine any like terms? Yeah, we can. So negative x squared plus an x squared makes 0. 2x actually isn't a like term, so we're gonna have a 2x, and a 3 plus a negative 15 is a negative 12. 2x minus 12. Done. That's what it means to combine functions. Subtract. This just means f of x minus g of x. Always be careful with subtraction. Use grouping symbols always, but always means always. But if you're a little bit sloppy, if you didn't use grouping symbols here, if you didn't group that, you would have got the right answer. You're not going to get the right answer if you don't use grouping symbols. Let me emphasize, if you don't use grouping symbols, your brain is going to think, okay, this is negative 2x squared plus 2x minus 12. Listen to what I just said, negative 2x squared plus 2x minus 12. Wrong. Group 3 minus x squared. There's a 1 in front, so no problem in the beginning, but this is going to become minus x squared minus 2x and plus 15. This minus sign needs to be distributed. Silly mistakes on relatively / very easy questions suck. Because I have to take off like 2 out of 3 points. That sucks. You forgot grouping symbols. I don't want to do that, but I have to. So add your grouping symbols, get all the easy points. Combine like terms, our final answer would be negative 2x squared minus 2x plus 18, which was different than what I barked at 60 seconds ago. And if you go back and watch the video, there's the proof. I remember saying like minus what? Minus 12. It's not minus 12. F g of x. I rephrase. F times g of x literally means probably what you think. Multiply these things. F of x times g of x, which means we're going to do 3 minus x squared times x squared plus 2x minus 15. Minus x squared. X squared, 2x minus 15. Do I have it written correctly?
Yes.
Okay. How do we multiply this? Distribute, FOIL, some people say, although that's, I'm not going to get into my teaching philosophy. You should know that, right? Ring a bell. You're just going to, here's how I do it. 3 times x squared is 3x squared. Then I do 3 times 2x. I call it 6x. 3 times negative 15, negative 45. All right, so let me get writing. 3 times x squared. 3 times 2x. 3 times minus 15. I'm halfway done. If you know that, cool. This is negative x to what power? 4. Awesome. just to remind you, talk it out to yourself. If this is a review, this means x times x, and this also means x times x. So you have green x, red x. All together, you have x to the fourth. And you multiply with the same base, just add the exponents. Don't go crazy. Keep it simple right now. X squared times x squared is x to the fourth. This is negative 2x cubed, and this is positive 15x squared. And obviously, we typically write stuff in highest degree, which is a fancy word for power, called standard form. So minus x to the fourth. I like to cross stuff out just because it's already a mess. Then I'm looking for exponents of 3. There's only one term that has that. See you later, buddy. Definitely have 2 terms with x squared, so 3 of them and 15 of them make 18 of them. Then minus 6x minus 45, and that is where we're at.
Is it minus 6x or is it plus 6x?
Just making sure you guys are paying attention. Yeah, very good. F divided by G. You get the vibe of this, right? F divided by G. So this is 3 minus x squared on top of x squared I'm going to get there. And we know how to add, combine like terms. We know how to subtract, distribute the minus sign, combine like terms. We know how to multiply, FOIL, whatever word you want to use there. Cool. And everyone knows long division like that too, right? Cool. So do the long division. And I'm just kidding. For right now, I'm just kidding. Polynomial division, that's definitely correct. And we know that, myself and a textbook author. So we'll come back to this. It is going to be in homework. Just structure it. We will learn polynomial division because most of us either didn't learn or definitely forgot it. So all you're going to do tonight or over this homework assignment for the division, know that there is more to come in the future. But right now, your math lab is going to mark it correct if you just write it like this, like literally structure it. But it is going to ask you a follow-up question, and it's going to ask you for the domain. We answered these questions a few lessons ago. You go back in the weekly content. I remember assigning like a factoring video. So 2 parts of domains. We don't want to divide by 0. So we're going to take x squared plus 2x plus, oops, my God, if I can get it right, that would be amazing. Minus 15, which is the expression in the denominator. And we're going to say, when are you 0? And those will be the excluded values. Let's review factoring. AC method requires a little side work. A times C, 1 times negative 15 is negative 15. And now 1 times negative 15, either you do this in your head or in scrap paper, whatever. Keep that over there. And you check your work as you go. By adding them, say, does it make 2? No. And then the more you say it to yourself, the better you know your multiplication facts, you probably will get there quickly. I'm not out to crush you with huge numbers. You should be able to get there within 30 seconds to a minute. 5 times negative 3 multiplies to negative 15 and add to 2. Split the middle. Why is that? Okay, I don't know, but I'll use this. Take out the GCF in the first two terms, which is x, you get x plus 5. Take out the GCF in the next two terms. You're 100% on the right path. If you get the common group, you are 100% not going to get any credit if those groups aren't the same. So find your error. It happens. You made something you thought was true, and then you're like, oh, wait a minute, I had this something backwards. But if those groups aren't the same, it's not going to work out. X plus 5, x minus 3. And let's hop back on the train. What the heck are we trying to do here? We're trying to figure out what makes this 0. At this point, I think it's inspection. What number plus 5 is going to make 0? What number minus 3 is going to make 0? Cool. We need to exclude -5 and 3. In interval notation, negative infinity, which one of these numbers are we going to hit first? So we're going to jump over it, and we do not include it, so we use a parenthesis. Negative infinity to -5. Union. Then we're going to arrive at 3. Union 3 to infinity. You need all those parts. I got 2 more questions. I have a lot more questions. I got 2 more, and we've done enough for tonight. Let's just end this chunk. What's up?
Wouldn't you have the brackets, the 3 and the 5?
I'll talk about it after class. I think most of us already know that. It's well established in this class, but I'll talk about it after. Question was, why is it not a square bracket versus a parentheses? If you still don't know that, you need to watch that interval notation or stay after, but let me get most of us who probably do out of here. F times G of 0. There's 2 ways to answer that question. Let's do the easiest one. Sub in 0 back at the beginning. What's the answer? 3. Cool. See how easy that was? Sub in 0 into G. Multiply 3 times -15. -45. That's it. Again, all this means is, f, not of x, but of actually a number, multiplied by g of that number. And you guys just told me a moment ago that, oh, I messed up my colors. F of 0, g of 0. You told me this was 3 correctly. You told me that this was -15 correctly. So our final answer is -45. Even simpler than algebra numbers. G divided by f of root 3. You know where this is going, I hope. We take g of root 3 and divide it by f of root 3. Let me cut to the chase here. Why did I put that on there? Let's go to f. What is the square root of 3 times itself? 3. And if you're not sure, you check on your calculator. But adding undoes subtraction, subtraction undoes adding. Multiplication undoes division, division undoes multiplication. Square root is undone by squaring, and squaring is undone by the square root. So no matter how crazy the symbol is, I have a square root and then a squaring, it cancels out. I just get 3. And 3 minus 3 is 0. And dividing by 0 needs to be excluded, and if not, we use a word called undefined. Part of tonight's lesson was learning new stuff, but there was review and all of that of things we've done. Factoring, writing undefined. I'll see you on Monday. We still have some content to do that will be on the test, but we are winding down. It's not a lot. And it's more like this. Okay, so we're over a hump in terms of material. See you, I get the day right, Monday. If you want a brief, I'm going to explain why We use square brackets and parentheses brackets. If you're good to go, see you Monday for last time. What's up?
Do we have any homework due for Monday?
Yeah, there's a transformations and there'll be a short combining. I haven't posted it yet because I didn't know what we get through, but
I didn't see one coming.
then it will be live by 7 o'clock tonight. I'll make sure it's posted so you guys can get started on that sooner than later. I got you. Way too many windows going.